Good morning and good evening, everyone. We hope everyone is doing well and having a good day. I am excited to welcome all of you to today's session, Blockchain 101 with Gloria Kimwala. Gloria is the CEO and founder of Shul, a startup that challenges the 10 billion global education industry by using blockchain to create, store, and verify microcertificates for undeserved learners. Shul offers a diverse and inclusive blockchain ecosystem that empowers people economically. Gloria was named one of the top 10 women in fintech by FinTech Ranking. She serves as the technical advisor of the board of directors for the Society of Women Coders and runs the Ask Gloria advice column in Reinvented magazine. During this session, Gloria is going to do a deep dive into Hyperledger developer ecosystem and explain how Project Dovetail can be leveraged for the design and the development of smart contracts on top of a blockchain. There will be time for Q&A at the end, so please, using the Q&A panel, feel free to send your questions throughout the session, and we'll make sure to answer all of them at the end. Last, before I pass the ball to Gloria, I just want to remind, for those of you that are participating in our online Silicon Valley IoT and Blockchain Hackathon, that the first 50 folks that send us a 30-second video showing how you can connect Project Care, which is the other project that is being featured during the hackathon that focuses on IoT. So using that project, connecting to any IoT device, will win a Particle Grove starter kit and Argon kit from Particle with a market value of $70. Once you register for the hackathon, you can submit your video through the hackathon's registration page. So, with no further ado, Gloria, please, the stage is yours.
Thank you. Hi, everyone, and thank you for joining this session. We're going to just go through a technical primer on blockchain. This webinar was originally designed by Gianna from Women of Color, Women Who Code Blockchain, and she assisted me in creating this specifically for y'all, so I just want to give her a little bit of credit. Women Who Code Blockchain, for those who don't know, is a space for people who identify as women to come learn different technical skills and go back and reinforce the workplace. So let me go ahead and go to the next slide. All right, so there are some topics that we will not be discussing in this current webinar. The side of cryptocurrency will not be discussed, so we won't be talking about cryptocurrencies or the different types of cryptocurrencies, their investments or anything of that nature. We're just going to be actually talking about the underlying technology underneath cryptocurrencies, which is the blockchain technology. So to go back to understand blockchain, you need to know a little bit about the Bitcoin white paper, which is like the beginning of the concept of peer-to-peer payments. And there, in the Bitcoin white paper, it was written by Satoshi Nakamoto. No one really knows who Satoshi Nakamoto is. It's kind of like a mystery. And the thing I like about that is there's some of the ideologies that say Satoshi could be me, Satoshi could be you. That's really not the point. The point of it is just the actual ecosystem and the anonymity that we still don't even know to this day. So the Bitcoin white paper deals with this discussion of having electronic cash that you could go back to back through a ledger that was still verifiable, but it was transparent at the same time. So in this introduction to blockchain, we'll have to understand that a blockchain is a consistent set of transactions that are cubed together. So you have one block that is linked to the next block, which is linked to the next block. And those blocks are linked through a cryptographic hash that we will discuss here in a little bit. Blockchain deals with what is called a distributed ledger technology, which means instead of having a ledger, like all the servers read off to one ledger, every server has a copy of the same ledger, and all of those ledgers update at the same time, and there's a source of truth. The blockchain is open source, so it's open to everyone. You can make the contributions that you need to in order to change or to build upon it. And it's immutable, which means that it cannot be changed. A blockchain is a chain of blocks all connected to each other, like a linked list. And then there is the hash. So from the first block, the Genesis block, there is a link. If you get to the next block, there's a link in the header. It's a cryptographic hash that links it to the previous block. So you can actually continue down all the different chains of blocks that are kind of nested. And it amplifies decentralization, where it's a network, or not just one central source of truth, but it's decentralized and has many different areas of truth. So what is this cryptographic hash that I keep talking about? A cryptographic hash is a hash function that is important. It's like an encryption algorithm. It's important for security systems. And the cryptographic hash is a process of converting data into a unique set of text screens. So when you look at the actual data, it's very specific. Like if it's, I love Gloria or I love blockchain and there's a capital B, that would be uniquely different from I love blockchain with a lowercase b. So the actual hashing is based on the unique set of strings that it's coming. It's based on the on the ASCII, and then it will turn out a different set of characters based on the text and the data that is stored on it. With that cryptographic hash, it's extremely difficult to reverse it, and you can't really duplicate it either. So it becomes a good security layer for blockchain because it can only go back to one specific spot. And your typical hash function looks a little bit like this, where the hash of x is equal to x over n, where the x model, and where the model symbol is the value of it. It sounds a little confusing, but if you see it actually performed, it's a little bit easier to understand. So a good way to think about hash functions is like the reverse. If ever you've played Uno, the game Uno, the reverse is, a card means like you get to go into another direction or go back. So cryptographic hash functions are one-way functions that help create a level of security in the system. So for given, x of 1 and x of 2, you have a hash of x1 to equal a hash of x2. Is only true if x1 is equal to x2, if it's the same. So if you have a set of data and you have another set of data, that hash is a hash of the first set of data is going to be equal to the hash of the second set of data, only if the data is exactly the same. So if anything else changes in that data, the hash of that data will be completely different. And a cryptographic hash function needs to be deterministic. So you can go to anders.com/blockchain.html, and it will take you to cryptographic hashes. So let me see if I can step out real quick so that we can play with this. I'm going to put it on for a second. Sorry about that. Hopefully yes. Okay, so hopefully y'all can see my screen. So if I had the block 1, we're just going to look at this hash spot right here at the bottom. And if I said, again, I love blockchain, right? So you can see that the set of strings has a unique, hash. But if I was to change this to capital B, the hash at the bottom is a completely different hash. That makes sense. And then if I was to come here into block 2 and say, you know, my name is Gloria, you'll see that it has a link. This right here, previous hash, is linked to this hash down here, this block's hash. And so when you get a blockchain or chain of blocks, these hashes it always comes with, you know, what number of block you're on, the nonce, the data, the cryptographic hash of the previous block, and the cryptographic hash of the current block. And because you can know what the previous block is, you always know the chain of it, because every block has the previous block until you get to the first block, which is called the genesis block. So I hope that at least brings some clarity to it for you for a little bit. Okay, let's see if I can go back to beautiful. So again, the blocks will always have the block ID, which would be the block number. It always has a data, and the data usually looks like different transactions that have happened in the ledger. And it always has the nonce that has happened, the cryptographic hash to the previous block, and then the hash for the current block. So if you want to take a moment to try it yourself, you can go ahead and do so. We can take a minute and you can do so. I'll give you a moment to just try it out. You can go to anders.com/blockchain and it should give you just different blocks that you can play around with. I'm going to just time it a minute. All right, we're going to keep going to the next slide. All right. So when you start to think of transactions and how they are processed, so I think sometimes people think transactions money, but we'll just consider it to be any type of exchanges. When you think of transactions, you have your transaction, a block, but you know the transaction is then listed on a block. Then it goes to be verified, and then it looks, the hash is looked up, and then there's the execution. So here, you know, A wants to send money to B. The transaction is represented online as a block to go into the blockchains. That block is broadcast to everybody on the network. Then those in the network have to approve and validate that block and say, yes, this is a verified transaction. And then the block then can be added to the chain of blocks, which then provides an immutable, transparent record of that transactions. And then the money goes from person A to person B. Yeah. So the one things that we have to really take into consideration is then like, how do you verify it once that comes into play? So again, you know, with different types of networks, whether it's blockchain, or Bitcoin, Ethereum, Hyperledger, they use like a ledger, you know, that's a list of the transactions that have or that happened during that block, and where people were before that list of transactions and where they are kind of after those. What's the state before the transaction? What's the state after it? And that ledger is usually in the data that's set within the block. So when we talk about like, how do we agree then that the data is true, those are called consensus protocols. And there's different ways of achieving consensus. So it can be like a proof of work protocol. Well, I'm saying consensus is a handshake, really, or agreement that says, yes, we all agree that this is the current state of the blocks and the transactions, and we can verify it by using this mechanism. So there are different types of consensus protocols. The ones that most people know are like the proof of work one, which is what Bitcoin is based off of, and it has the whole aspect of using miners. So to solve a problem, you have a puzzle. The first person that fixes that puzzle says, yes, this is the state of the network. And then everybody agrees that's the state. They move on and try to fix another puzzle. That's kind of like the proof of work, is trying to be that first person to solve that puzzle. Then you have like a proof of stake algorithm, where you stake something into the pool, and then if everybody agrees and you don't lose your stake. That one's a little interesting. That's kind of what people are going towards from a scalability perspective. You have there's a lot more than just these proof of stake and proof of work algorithms, but those ones are the ones that are like majority discussed about. You could go down a little bit further, but I think usually for beginners, they usually start with a proof of work and proof of stake. But there's also like proof of authority. There's quite a different group. Okay. So what is some of the benefits of a blockchain network? It is tamper resistant because nothing can be deleted from it. Everything is transparent. Everybody has the actual records of it. So so everybody has a copy of the records. There's no way that something can be left off of the ledgers or anything like that. The other aspect of it is that it's open source, so anyone can add to it. It's open and available for everybody to build on top of it. There's an identity management security by encryption. So when you are using like addresses, you have like a public address and a private address, and it's kind of like having like a bank account and a PIN code. Like your bank account is public. It says this is an account, but your PIN code is associated to that account, and is only you know your PIN code. That's the same with a public key and a private key. A public key says like, yes, you can send it here to, send transactions to this person and I identify it as me, but I can verify it's me via my public key too. It's always in real time. So it auto syncs every copy almost instantaneously. So everybody's all on the same page, all at the same time. You don't have to worry about any type of like delays or someone being behind a block or whatnot. Theoretically, like you can't be behind a block. And yeah. So there are a lot of different use cases right now in blockchain. This list is not by any means extensive. And even within this list, there's probably even more that we could go into. A lot of times people hear about it in the financial circles. It's talk about in trading, derivatives. It's used in media for rights, and music for musical rights. It's used for record keeping, whether it is insurance, hospitals. It's used for like license and identification in government. So this, if you take a moment to take a look at this, this is some of the things that it's being used for right now. There's also have things like zero loss lotteries. Like there's new things that become opportunities now because of blockchain that we hadn't previously had. So when you're thinking about either your hackathon project, I always try to encourage people to think outside the box. Like, this is by no means the list that you have to make your confines in. Yeah, there's quite a lot of cool things that happen. I know for my company deals with it within education in order to have decentralized and distributed education. But my friends also have ones that deal with music rights and ownership, where the artists can then share their music, and all the proceeds from the music, they own all the music rights, and all the plays from the music go directly to them. So it does a lot of cutting out like middlemen via smart contracts, and that is something that's can be beneficial to a lot of different industries. Okay, so here starts the discussion about private blockchains versus public blockchains, and so we'll go over a little bit about that too. So there's two types of blockchains. You have a private blockchain and a public blockchain. And within a public blockchain, it's anybody in the whole world can join. It's completely open to all different types of people. So that can be what Ethereum kind of looks like. Their transaction ledger is also visible to anybody that's in their network. So it's completely decentralized. It has no other controlling network over it. And so one of the things that becomes extremely important is data security, from the fact that the data, once validated on the blockchain, cannot be tampered with. And it's considered permissionless, so you don't need to have permission to engage with the blockchain. Now, the other type of blockchains that they have are called private blockchains. And the private blockchains are more network channels between two or more. So it's kind of like a blockchain with a selected group of people, or a selected group of participants in it. Those transaction ledgers are only visible to the group that are in that private network. So there is some source of decentralization among the parties that are inside that network, but there is restrictions on who can participate in it and who cannot. And so that is also called permissioned blockchains versus private blockchains. And private blockchains tend to be used, private blockchains tend to be used a lot in companies and industries because of the different types of goals that the shared goals that different parties within industries have. Private blockchains kind of work really, really well to create the integrity aspect where no one else can join it, but they can still get work done a lot faster within those private blockchains. So we're gonna go a little bit into Hyperledger. Hyperledger is a permissioned blockchain. It's a private blockchain. And it is what Project Dovetail talks to. On the other hand, they've done both Hyperledger and Corda. So Hyperledger was created to further blockchains for enterprises. It was created in 2015 when a bunch of different companies realized that they could do more within the blockchain spaces if they just worked together and utilized the blockchain technology for that purpose. It is open source where anyone can contribute to Hyperledger itself. But the channels that you create, they're going to be private within the groups that you have. And it's put under the guardianship of the Linux Foundation. So currently within Hyperledger, there is about 200 different organizations that have members in the Hyperledger community, and it's a very strong community. There's meetups all over and a lot of fun different projects. And the people who use Hyperledger think that blockchain would involve like modular open source platforms that are easier to use. So in order to engage with the blockchain, you have a smart contract, and the smart contract is basically just a computer program that has business logic for your applications. So, and it's basically the contract that you write to deal with the applications. And once the smart contract is deployed, no one can change anything on it. It remains like immutable. And the only way to change a smart contract is you need to redeploy a new one onto the network. And smart contracts operate with like a very limited execution content. So they can assess their own state, the context of the transactions that are called to them, and some of the information about the most recent block. So there's some information that the smart contract can access where you can eliminate as much like human interaction as possible. Perfect. So here is just a couple of different types of smart contracts that you can have. Right now, within the blockchain space, we see like smart legal contracts that involve strict legal recourses in case parties for the parties that are involved. So they're just like strict legal frameworks within the smart contracts or agreements. We also see some decentralized autonomous organizations where communities that exist on the blockchain, where the community may be defined by a set of rules and code that is like put in the smart contract to adhere to those rules. And then you see like application logic contracts and the smart contracts that contain application specific code that work in conjunction with other smart contracts too. And it says Project Dovetail can create all types of smart contracts. So the Project Dovetail that you're going to be utilizing is a great tool for smart contracts and to leverage those smart contracts that you need to make those agreements. Okay, so why smart contracts? And so smart contracts, for me personally, I like smart contracts because it does eliminate some of the, it speeds up the process. It eliminates some of the hurdles that can come abound when you have to deal with human interaction. So the one thing I can think of is like if we were thinking about supply chain, or let's say for me, I'm trying to get into another country and I need like 5 different stamps and you have to go to different agencies to get those stamps and you take your paperwork and whatnot. If they were smart contracts that were, in each agency, it would be able to say, to see like when you had those stamps and not wait for like the person to have to stamp it. It would just be able to speed up and become more efficient to have a computer program or some computer logic be able to say like, okay, these are here, that all of this information is correct. We're going to go ahead and start the process from reading the contracts. So it's embedded in trust and transparency into the business process. There's precise transactions that happen instantly. It's secure and reliable data. You can always look back to that. And it minimizes cost. And I think overall, it's just a very fluid and easy way to do business. So when you start to think of where can smart contracts or blockchains be utilized, I always like to start with a pain point. And like if there's an area where you're thinking, goodness gracious, this process is so slow and this process seems so archaic, usually that's probably something that a blockchain would be able to handle if it's dealing with, social contracts and things of that nature. So yeah. And we see it being used in a lot of different ways currently. You have the fintech space that deals with, cryptocurrencies, money transferring, cross-border payments. I don't know if anyone's ever tried to deal with that whole process, but it's usually a pain. And dealing with fintech and cryptocurrencies or blockchain in that space, it has brought so much ease to just being able to have someone's address, public address, and send funds that way. It's been great. And then it also has a very low barrier to entry. So instead of having to have like a whole share of something, you can even have like these micro shares that make it very easy to transact in that way. Another spot that we see is the cross change between like blockchain and AI. We'll be talking about that a little bit more when we have our panel, our keynote later this week. So I'll just keep some tidbits there. Blockchain and securing the Internet of Things has also been a big trend. And then the different types of consortiums that they've had has also been really interesting to watch. So there's a lot of different interactions that are happening currently within the blockchain space. And it's kind of going to continue to grow. It's grown quite a bit since I first started to interact with it. So it's great to see it to continue to have new innovations coming and new applications to the technology. So yeah, let's go with questions. Does anyone have any questions, or I can talk about how I see some of the smart contracts that I see currently being used. Or use case would be one of the areas I think of like right now with all of the different protests that are going on is like different types of social contracts that you can have. In filing for a permit to have a protest, it usually takes 30 days, but like to organize one takes like 20 minutes. So it'd be great if there was some type of way to have like a smart contract that said, you know, you filled out your information as to like when it was going to be, and then every other agency would look at that smart contract and see the information that they needed and issue out like a permit at the end of it. That process would be able to be done on blockchain if all the different agencies were, you know, on the chain and just signed with their approvals what they needed in the contract. But it shouldn't have to take, you know, the 30 days. So there's some type of things that could go on blockchains if we start to look at it the lens of, oh, wow, this could be a blockchain solution, because a lot of times it's just social contracts versus real contracts, or creating actual legal contracts and putting them on blockchain too. So I see a question. Let me see what the question is. Hold on.
Excellent. Yeah, I'm happy to read the questions
Yeah.
to you, Gloria. So the first question here is if Hyperledger, or, you know, I think this extends to, you know, any blockchain in general, right? Like if it's a store in a specific location, country-wise. So I guess the real question here is like if you have like, let's say a network, right, that is going to be established in the US, then the blockchain would necessarily have to be, you know, deployed in the US, or it could be deployed in a different country.
Oh, that's a good question. The blockchain is deployed against everyone's servers that are connected to the blockchain. So it can be anywhere around the country. Does that make sense? So yeah, it's not just deployed in the country where you're at. It's like any other servers that are, if you're on a public one, it's the other servers that are connected to your network, wherever that may be.
Yeah, and in your experience, I mean, how do you see, for example, like let's say international consortiums, right,
Yeah.
where you have entities from different countries trying to collaborate? You know, there's different data privacy, obviously, laws, right, and industry-specific laws that they vary quite a bit depending on the country that you're in. So, in your experience, how do you see that being managed?
Yeah, it's been kind of interesting actually from that perspective, because sometimes the data, because the data is encrypted, it's like only seen, the data itself is encrypted, you know, so with the hashes, so that most of the time the data that you get is like not like the message, it's the hash to the data. But we've been seeing being used is blockchain like from a journalistic perspective, being utilized for people to get information back and forth and messages back and forth. I'm trying to think of how, there's a lot of like, the technology kind of moves faster than the laws do per se. And so there's a lot of ways to get around it via the encryption components of it. Now with regulations, when you have an actual entity, you have to really kind of toe a line and say like, okay, are we going to toe the line with the regulations, and are we going to toe the line with the technology, and like, what are we going to do with that? And I think it's a lot of discussions that are personal to each organization and each leader of like, how much of that line is they going to toe? Are they going to just take it as a slap in the hand, or are they going to move forward? There are the privacy sections. And so from a privacy perspective, there's a lot of, know your customer. There's a lot of ways that we are getting around that. And they do it a lot of times through like mathematical proofs, like zero knowledge proofs is a good way to say like, hey, this information, we can keep information private and say, yes, you're who you are. So there's a lot of like aspects through mathematics and things like that allow you to still be in line and keep privacy and keep privacy at the forefront, but at the same time, keep integrity of the blockchain per se. Does that answer the question?
Okay. Yeah, no, definitely. Yeah, and I guess it's an extension of that. In your experience, for example, whenever you have either a federal institution that needs to be part of the process, right? Like whether it's for taxing purposes, let's say, or
yes.
From a law enforcement point of view, right? Like
yes.
enforcing the legal aspect of the smart contract. Mm-hmm. What do you see sort of like a best practice, right, in those scenarios, industry-wise? Is there any particular trend that you're seeing, or it's almost like at the consortium level, each consortium then tries to figure out how to handle that aspect of the deployment?
Yeah, so a lot of times that question is at a consortium level, and the trends that I see is more like it happens to be with like the consortium levels or the protocol levels. Sometimes we see something that deals with like a homographic hash per se, but sometimes it's just the proofs. I don't usually deal too much with law enforcement on that angles, but sometimes it happens to be like within the decentralized, oh yeah, okay, hold on, question, let me go back. Sometimes it happens to be within the governance and the decentralized autonomous organizations, and how they're gonna deal with governance per se, on how they're gonna deal with like voting, and how they're gonna deal with who has rights, and how do we say that this is the right way per se. When you bring a government entity in, they can still have their stake and then have their side into it too. But that type of decisions as to like who's right or whose truth or whose perspective is correct, it still is a governance call as to which way we're going to go. And that happens at a higher level than just the individual smart contract. But when you're writing the contract, there's usually things that you have to keep in mind. So if you are partnering with like, let's say a hospital, and they have HIPAA laws that you have to make sure that you keep in place, then you have to make sure that privacy is, top of mind, and that you're using really good encryption technologies to keep that data private.
Okay, great. And just a quick commercial, as you mentioned, next Monday we're going to have the keynote for the hackathon, where as part of the opening session, we're going to have a panel. We'll be talking about some of the major trends that we're seeing on the IoT side, on blockchain, as well as the two of them together. So, definitely something I guess we can say to be continued on Monday, this conversation. But another question that came in here, in terms of like the cost of the actual deployment, can you give us an idea of what you're seeing of the cost of putting transactions in Hyperledger in terms of dollars, for example?
Yeah, so with I can't say it with Hyperledger with cost because most of my contracts are in Ethereum, so I know more of the transactions on that side. So let me see what the current cost of gas is. So one of the questions is when you write your blockchain, you're writing it back to the network. It's called it takes what is in Ethereum where I usually write on. It's called gas or ether, and that is processing power. And so there is like a cost associated with it. Let me see if I can figure out what the cost currently of gas is for Hyperledger, or I'll put it in the chat.
Sure thing. Yes.
Sure.
Excellent.
I'd have to look at that one up for a second.
And you know what? Like, how about like this? While you take a look into that question, let me take the ball here for a second. Yes. And share something here with the audience.
Yes, that's fine. Let me stop screen sharing.
Yeah, thank you.
There you go.
Excellent. Thank you so much. All right, perfect. Yeah, so hopefully you can see my screen. And as I mentioned, so this session today is part of our online hackathon. If you haven't registered, or if you want to go to the registration page to get more information on the rules, the challenges, the prizes, and whatnot, the easiest way to get to the page is just go to hackerearth.com. Once you're on the main page, go to the For Developers section on the top. If you scroll down, then you'll find our hackathon in there. So if you click on Start Now, that will open a new tab that will take you straight to our registration page. So I just want to highlight a couple of things on the page here for you. Well, I guess the first thing is the dates, right? So as you know, we are officially open for business, so to speak. The hackathon will run until June 26th. That day at 4 p.m. we'll close the submission portal. So make sure to submit your project before then. On the top of the page, the first thing that you will want to do is register for the hackathon. As you scroll down, you'll see different resources in here. On the main landing part, you'll find the rules for the mini challenge that I described, where you can just use Project Air from TIBCO Labs and connect it to any IoT device, and then just submit a 30-second video of how it worked for you, and you'll be getting a prize. Now, for the actual hackathon, there's going to be different challenges. There's the TIBCO challenge, which features, again, Project Air and Project Dovetail, the one that we're talking about today. From Women Who Code, there is a separate challenge. And Gloria, do you want to tell us a little bit more about this?
Yeah. So yeah, for the Women Who Code challenge, deals with the UN social sustainable development goals, and so we thought that it would be great if we could just kind of look at the sustainable development goals and kind of partner along our beliefs and values with Women in Code. So we're looking at the economic empowerment component of the sustainable development goals. I'm so sorry, which are SDGs 1, 8, and 10. But if you do find a sustainable development goal that you can still use that uses blockchain, I'll still consider it. If you just say which SDG it is, you can click on the links to do that. And those goals, the criteria that we'll be judging it upon are listed, but it deals with not only the integration of Project Dovetail, but also, there we go. There's the Sustainable Development Goals. You can go out to the UN's website. They have a whole bunch of it, and it deals with dealing with poverty. Number 16 is dealing with the just world. Number, I think 4 or 5 deals with education. So there's a lot of different goals that you can align your project with, and we'll consider any of those goals. So the criteria for the challenge falls into 3 different points: the inclusion of Project Dovetail and if you tried to implement it, if you asked questions about it, if you got it successfully implemented, and if you learned something new and shared it, then it has the criteria for the Sustainable Development Goals. And then it also has the component of Women Who Code, having someone who identifies as a woman on your team in a technical role, amplifying a woman's voice. These are all different components of getting more women to tech that usually don't get discussed. And so we thought that we would put that little component in the challenge as well. So those are the judging criteria for your project in order to get our point.
Excellent. Excellent. Thank you for that. In addition to that, there's, in this section, you can find more information about the prizes. For example, the challenge from Women Who Code is eligible for a $1,000 Amazon voucher for the team, for the winning team. In addition to the landing page, then there's the resources section. In here, you can find information about the sessions that we've been talking about. So the next one up is on June 15, next Monday, is the Keynote with our CTO, TIBCO CTO, Nelson Petrocek, followed by the Keynote panel that I was talking about before. Gloria is going to be part of the Keynote panel. So thanks for that, Gloria. And then yesterday we had we kick off the sessions, right? We had like a session on Project Air, another one on Project Dovetail. The recordings of those sessions will be made available through the site on June 11th. And, also on June 15th and June 22nd, we're going to have office hours. So in case that, you get started, if you have any questions, any doubts, or any things that you want to share with the group, feel free to attend those office hours. There's also a discussion section on the site as well. So feel free to leverage this part of the site to collaborate with other participants. And last, the part that I want to highlight is on the official rules. Here's where you can find pretty much all the information and any questions that you may have. So in terms of, for example, the criteria that we're going to use to evaluate the projects, the winners, they're going to be announced or posted on the site on June 30th. So, registration or submission ends on the 26th, and then the winners will be announced on the 30th. And I think that's about it. So with that, Gloria, any closing thoughts?
I don't have any closing thoughts. I'm actually really excited to see what people come up with. If you do have any questions for me specifically, you can always reach out to me at gkambwala on Twitter or any institutes like that. I'm pretty easy to get a hold of, or you could save your questions for the keynote and I'll be more than happy to answer them there.
Excellent. Well, I'll definitely see you again on Monday. And to all of you that attended today, thank you for your time and see you next time. Bye.
Bye.